So let's talk about virtualization first. And to understand virtualization, or to get to a point of being able to understand it, it's important to understand client-server architecture. And client-server architecture still exists today. It was the talk of town, the thing that everybody was trying to do, 15, 20 years, maybe a little bit more years ago. But the idea is very simple. You have clients and you have a server. The clients make requests. The server goes out, gets whatever information is required to meet those requests, and then brings the information back to the client. So think about it in a restaurant, right? If you're in a restaurant, you don't just go and necessarily, you don't bring your own food and place it down and start eating it. You have a menu, you know what the options are, you tell the waiter what you want, the waiter goes and puts the order and brings it back to you. So it's kind of that same client-server type relationship. And the technology that's important to cloud is that client-server, right? Because again, we're not running on one computer. We're going to be running across the internet. And so you need one side of that connection to be the client, to be able to make the requests. And you need the other side of that connection to be the server, to be able to serve those requests. And often the server side is going to have some kind of a database attached to it, or some other kind of connection where it can get the information that it needs. All right, so we're going to talk about virtualization. And as I said, really, really, really important to understand virtualization. It's really the fundamental concept of cloud computing, and it's what has made cloud computing so cost-effective and efficient. So if I think about a traditional architecture or a server that I bought some years ago, let's say 30 years ago, it would have had the hardware, the operating system, and then the application. Think about your own laptop. This is exactly how things are set up, right? Hardware, operating system, and then you can run however many number of applications, but it's one computer for one person. Now, imagine if I could do something a little bit different, right? If I could take that hardware and if I could create multiple operating systems on it, and then allow different users to connect to those operating systems without those users knowing anything about the other user. So this user would know what OS this is, this user would know what this OS is, and then the apps running on those OSs, again, I would know, these users would only know about their own apps and their own operating system. So on top of the, and so there's this, and we'll get into more details about hypervisors, but we essentially have the ability to split the hardware into three now. And now what happens, if I needed to give a computer to three people, I would give her one and him one and her one, and I have to buy three computers. But now I can buy one computer, and as long as it can provide a user interface somehow, then I can this hardware doesn't necessarily have to be 3 times as big, because they're not all going to be using the computer at the same time. And so I can virtualize the operating system on top of this hardware, or I can virtualize the hardware, depending on how you look at it, and be able to provide a virtual computer to each of these users. All right, instead of a physical server or a physical computer, I'm not handing to somebody, I'm giving them a virtual, a piece, a slice, a computer, and they're going to need some user interface to be able to access it, but I'm just giving them a piece of it. All right, let's see how now this client server and virtualization works together. So, I have a web application, right? And I could have any sort of front end technology to run that, or for the front end to be written in any of these kind of languages. And then you might have some sort of a middle tier that's processing it. And then you're going to have the back end, which is the database, which is serving up the information, returning the request. And so I've put this information. So I still have a client-server relationship, right? You see that the client is making a request, and then the server is returning the information, and then through some middle layer to apply some logic. But does everybody see how this is a client server, right? But what's happening here? If I've got this thing not used very heavily and this thing not used heavily and this thing not used heavily. There aren't too many users on it. All of a sudden now I've got a lot of idle capacity. So my servers are there. I've bought them. They're huge, but they're not running all the time at full capacity. And so, this gives us an opportunity to become more efficient with our compute power. All right. So again, think about what the previous diagram was, right? The previous diagram was 1, 2, 3 servers, right? Now, what's going to happen? If I virtualize it, then I've got 3 virtual environments. Just like I had 3 virtual computers for those 3 virtual users, I have 3 virtual OSs. They can be different or they can be the same. And I have 3 apps running on them. One is running the front end web server. One might be running some middle tier, and one is going to be running the database. So 3 different apps. They don't know about each other. They're still communicating the same way over the using whatever client server protocol that they were using. But now I've consolidated that all into one piece of hardware. So this is one way that you can use virtualization. Okay, by taking different applications or different services, if you will, on 3 different pieces of hardware and putting them onto one piece of hardware. So you see, I still have the 3 applications, and below you'll see still 3 operating systems. But what have I done? I've been able to consolidate so that I'm using only 1 server. And that's going to allow me to gain some cost efficiency. Okay, and the question is, why virtualization? And the analogy that we're using here is, if you only need milk, why are you going to buy the cow? You just need the milk. And so in the same way, if you don't need all of that hardware that's associated with that 1 server, then why are you going to buy the whole thing? Why just not buy a portion of it, but buy that portion that you need? And so there's these concepts in the cloud of scaling out, scaling in, scaling up, and scaling down. All right, because the question that somebody just asked is, does that hardware need to be as powerful, or does it need to be more powerful? The answer is, well, kind of, but you have a lot of flexibility in the cloud, especially when it comes to scaling. So for example, if let's say, for example, you have originally your 3 pieces of hardware, 1 CPU, 1 CPU, 1 CPU. So that's 3 CPUs. But I decide, okay, instead of 3 CPUs, I'm going to buy a server in the cloud that's only 2 CPUs. And so I get that server with 2 CPUs, and I virtualize it for those 3 different applications, and it starts to run. And I realize, oh, this is not big enough. I actually do need all the 3 CPUs. So what I'm going to do is I'm going to scale up. I'm going to increase the number of CPUs. And it's easy to do in the cloud. It's literally the click of a button. It just takes another piece of hardware, virtualizes it, and your software is then running on a new piece of hardware that has, or a new virtual server that has 3 CPUs that's dedicated to it. Okay, so that's scaling up. Or if let's say originally it was 1, 1, or let's say originally it was 6, and I decided, okay, I'm going to buy one with all 6, and I realize it's too much, then I can scale down and I can get a server with 5 CPUs or 4 CPUs or whatever the number is. So I can scale down. So that's one way to do it. But the more efficient and the more economical and the more technologically effective way to do it is doing scaling out and scaling in. And there's a difference between scaling up and scaling out. So when I scale up, I increase the number of resources. I increase my CPU, or I increase my memory, or I increase the disk space on one particular virtual server. Scaling out, what I do is I take one particular block. So let's say this block here, okay, and I want to scale out. I'm going to just copy it. I'm just going to replicate it. So now users can either connect to this set of servers, or they can connect to this set of servers. Now, it's a little bit more complex than that. I'm not going to, because there's a lot more to talk about when we talk about scaling. But the point is that now users can connect to this one, and they can connect to this one. So think about back to when we talked about how Amazon got into Amazon Web Services. So during their low periods, they just had this. And so their users were just connecting to this. And then at Christmas time, all of a sudden they had more users. So they just copied it, made another replica over here, copied it, made another replica over here. And all of a sudden, now they have 3 times the capacity scaled out. Now, Christmas is over, everyone's in a food coma, no one can shop anymore. And so all of a sudden they start to scale in. So they just get rid of this, they get rid of this, and all that's left is 1. So scaling out and scaling in is actually the way that's most effective to scale in the cloud. And it's only, you're only able to really do this effectively and cost effectively because of virtualization. Okay, and then, you know, what this slide is showing is that you have different types of virtualization, right? And it's really going to depend on kind of the use case, what you're dealing with. But you can either virtualize your storage, you can virtualize your OS, you can virtualize your servers, and then you can also virtualize your software. And the idea is just being able to, and when we get into containerization, you'll see how, you know, software is in some ways virtualized that way. But when you start to virtualize, you're essentially providing an interface to whatever's accessing it so that you can have multiple copies of the same thing or the same type of thing, but maybe different flavors. So when we talk about OS, you know, you're going to have different flavors of that OS, but your OS is still virtualized.